All right, yesterday, or not yesterday, but today was the last time we met, we were estimating a population proportion. In other words, given a proportion, a probability, and a percent. Now, we're going to be doing 7.3, which should be estimating mean. Okay? That's this section here. So, in 7.2, we're estimating a proportion try it again. So in 7.2, we estimated a proportion a percentage and a decimal. Okay? And in this section 7.3, we're going to estimate a mean. Okay? Now, in order to estimate the mean, you're going to have a formula. And that's what we're fixing to look at now. Like I say, it's not very difficult. Also, make a note, the sample mean is the best point estimate of the population mean. Okay? You need to write that down. The population mean is the best point estimate of the population mean. We will also be able to find a sample size just like we did yesterday, day before yesterday. Don't need to get picky. And figure out on a 90% confidence level, 95% confidence level. Now again, the book may ask you for 80% and 85%, but I usually don't. I show you how to do it, but most of the time, you're going to be finding 90 to 199%. All right? Most of the time. Of course, requirement of normality or n is greater than 30, that still applies. Most of them will say normally distributed, so you won't have to worry about it. And here is your formula for the margin of error. Where the margin of error is found from the following: E, margin of error, is equal to T sub alpha sub 2, alpha over 2, and we will show you how to find your T, over times the standard deviation over the square root of n. And the degrees of freedom for your table is n minus 1, and we'll talk about that. So you might want to write that down, that formula for the margin of error. Says, when constructing a confidence interval from the original set of data values, round limits to one more decimal place than is used for the original set. So if your original set of data is to the tenths, you round to the hundredths. If it's in the hundredths, you round to the thousandths. Okay? And they should give us a problem probably on the next page. Okay, student T distribution, write that down. Does it look familiar? Yes, it does. Looks kind of like your degrees of freedom, remember? I mean, not your degrees of freedom. The 6.5, I can't remember what it was called, but when you take the standard deviation and divide by the square root of n, remember that? I can't think of the name of it right now, but anyway, write that formula down. T is equal to x bar minus mu over S, which is the standard deviation of the sample, over the square root of n. Now, let me talk to you for a second. Bring it back down, Vanna, please. Do you remember in chapter 1 when I told you that you need to know your parameters and your statistics, because if you're ever in a presentation in your job and somebody throws an S up there versus a sigma, that you know that it's the sample and the population? Do you remember me telling you that? Well, this is a prime example. What is that guy right there? I'm pointing to the X bar. What is that? Of the mean of the sample. See, this is the mean of the sample. What's mu? Mean of the what? Population. And the reason you know that is because you know those parameters at the beginning. The parameters for the population is mu and sigma. Remember, they're Greek letters. Greek letters, population, parameter. Population, parameter. Greek letters. Sample is just regular letters. X and S. So what's that? What's this S right here? That is the standard deviation for the what? For the what? Sample. See, that's how you need to be familiar with that whenever you go into another statistics course, or whether you go into a presentation where other directors or other supervisors are giving their presentation, and they throw this up there, or they throw something up there that's got S and X and X bar and mu, and then you know what's going on. And you surely don't sound ignorant. All right? Remember, degrees of freedom is n minus 1. We'll get to that when we get to the table. A3 is the table. Okay? Now, I'm not spending a lot of time on the reading part. Y'all can do that. I want to get to the example. There should have been an example on this page. There we go. All right. A sample size, n is equal to 12. Well, Hubert, I thought you said n has to be over 30. But what else does it say? Normally what? Normally distributed. So the n being greater than 30 goes out the window. It says normally distributed. So a sample size of n is a simple random sample selected from normally distributed population, blah, blah, blah. Find the critical value, t sub alpha over 2, corresponding to a what? 95% confidence level. So first of all, let's write down what we know. All right? So I'm going to take my dang old tool. Oh, gosh, no, I don't want to shut down. And we'll just pull this guy out, save, yeah, and insert. Let's go to the whiteboard while I have more room. And insert media. Dang old pictures. There we go. Alright, now this guy says a sample of n is equal to 12, so you're going to write down everything we have. Now when I say everything, I mean everything. Don't just sit there and say n is equal to 12 and 95%. No, that's not what I mean. We're going to write down n is equal to 12, and we're going to say 95% confidence level means that alpha is equal to what? 0.05 Hubert. That's right, class. Which means that alpha over 2 is equal to what? What's half of 5 cents? 2.5 cents. That's what I mean by writing down all the information. Now you just have to look up your t-value for 0.025. Now how do you do that? Well, you look in your book, your A3 table, or, let me write this down. Where do you find your t-values? Your t-values can be found in your A3 table in your book, or Google Triola 12th edition, or something like this, A3 table, or something like that. So I'm going to do that. So we go to our handy dandy Google. Triola 12th edition A3 table. Golly, look at there. Oops, wrong one. This one. There we go. And it's supposed to have an A3 table somewhere. A3, look at there. Alright. And degrees of freedom be 12 minus 1 is what? 11. So here's the section. Hold on a second. Yeah, just come on in whenever, that's fine. Oh, Lauren, go get the pizza. Lauren, go get the pizza. I don't have $1. This is $1. Hurry up, they're calling second time. Go. Okay. So, here is, where's my, oh, there it is. Okay. So 11, 12 minus 1 is 11. Okay. And we have a alpha over 2 of what? Alpha divided by 2, that's 2 tails, is 0.025, which would be this one right here. Oh, wait a minute, there it is. 0.2, there we go. 0.025, which would be 2.201. And take your handy dandy yellow marker. And it's 2.201. So, let's go back. And we know that our T is equal to, what'd I say, 2.201? Trying to find my, there we go. And that's where you get it right here. Okay? And we just found the critical value. In the 7.2, you found your critical value by doing your z-score. Remember the z-score? You may be able to use your calculator. Go under math. Let me go and look for it right quick. It's been a while since I've done the t-table, but let me see if I can find it. It should be under math and then probability. So math, probability. No, it might be under stat, test, t-test. Maybe the t-test, I don't know. No, that's doing it for, I'll have to look it up. I hadn't used it in a while. So second, let me try second bars. No, I'll have to look it up. I'm not familiar with this, how to use a calculator with the t-test. So we'll just go from there. Now they probably have the pizza, so if y'all want to go get something to drink, or if y'all want to go get a napkin or something, y'all go ahead and feel free to do that. And y'all can eat. Now everybody can eat. All right. I thought it said somewhere on here where I'll find it.
Merry Christmas.
Thank you. Oh, that's nice. Let's see, run this time. Little tutorial right here. That's nice. I like that. Shows you how to use the table.
Almost every statistics textbook has a t-table that looks like this, with a few differences forced on the book author by working on paper. First,
That's nice.
the picture of the density shown above the table can't move. That's a shame, because the shape of the t-distribution changes for different degrees of freedom.
Okay. All right. We'll probably figure out how to do the technology. It'll probably show it somewhere. There's a margin of error. Okay. All right, let's take a look at this one right here. It says constructing a confidence interval highway speeds. Write down, if you don't have a book, write down example 2 and just write down these speeds right here. We're going to put them in the TI-83, and we're going to find the confidence interval. So listed below are speeds measured from southbound traffic on I-280 near California or in California. This simple random sample was obtained at 3:30 on a weekday. The speed limit for this road is 65 miles an hour. Use the sample data to construct a 95% confidence interval. So therefore alpha is equal to 0.05. Alpha over 2 is equal to what? 0.025, Hubert. That's right, class. And what is n? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is degree of freedom? Say again? 11, Hubert. That's right, class. All I heard was no. That's all I heard. Maybe y'all can figure out what that means. So go ahead and do that. Put it in order first. And the reason I'm going to put it in the calculator is so you can see how to use the t-test. I believe the t-test will work as long as we have data in there. Anybody in here work at Bojangles? Their tea tastes funny. Is it just me, or does their tea taste funny? It does have a wang to it, doesn't it? Okay. Okay, nobody asked you. I believe they're putting poison in it. Yeah, I do. I don't drink it. But I think somebody ought to tell them that their tea tastes funny. It's like they're trying to mix some raspberry or something in there. Duh.
It's legendary.
It's what?
That's what they claim.
It ain't legendary. Now, if you want legendary tea, dang old Zaxby's pretty good, but Kentucky Fried Chicken used to have the best tea. But Kentucky Fried Chicken sucks now. I don't know what they doing, but they need somebody, what that guy did for Hardee's. It went in and turned everything around, and man, best hamburgers at Hardee's by far. Huh?
If you get a Gringle, the water it's the water in your own. If you get a Gringle, it doesn't taste the same. Like Bojangles.
Zaxby's is right beside Bojangles.
No, I'm
And-
saying in Gringle, like
Mhm.
you know, Bojangles Coke 181 is just nasty.
Yeah.
If you get a Gringle, the water everywhere is going to taste as bad as it does.
Hmm.
It's like the water here was yellow for a little while.
Well, that's all right. When I was in Saudi Arabia, I drank water that wasn't even drinkable. I paid for it. We thought it was drinkable, but it wasn't. All right, so let's put it in order. Let's go through, and I'm just going to punch them in the handy dandy calculator, and we're going to go from there. And I'm going to go to, I'm not much on stat. There it is, stat. I have to look. All right, we're going to go to edit, table. And I'm going to put it all in the first line. So I have to be careful here because I have to use the keyboard because I hit the wrong, if I use this keyboard, it won't do it right. So 62, 61, 61, 57, 61, 54, 59, 58, 59, 59, no, 69. Let's see, 54, 59, 58, 59, 69. Sorry. I wanted to make sure I was right before I changed it. 69, 60, and 67. Well, Hubert, how do you put them in order? Well, you hit math or stat, and you go to sort A, and type in second function L1, and enter. Now you go back to stat, sort, edit just to check it, and look at there, it's a miracle. And we got to take out that other one. I just like to take them out. I'm sorry. I just don't like to have all kinds of different numbers on them. Okay, so there's our list. Everybody got it? All right. Now, go to stat, test, and do a t-test, or let's see, probably would be a sample 2 test, or sample test, I'm not sure, but
How do I make my L2 stuff go away?
okay. Why do you want to ask me that now? You should have asked me that while
While
ago.
I'm trying.
Okay, well, you didn't know how to do it. You should have asked me when you didn't know how to do it. Anyway, hit stat and edit. Go over to the L2. Do not go to the top L2. Do not do that, because if you hit delete with that, that'll delete the whole column, and then you got to go through and insert another column. Do not do that. Go down to the numbers and just hit delete, 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 delete. Got it? All right, stat, calculate. I'm just looking, so I think it's the last one, test. And it's either this one or it's the two sample test. I believe it's this one. Stats, x of 1, x of 0, data, stat, data. There we go, data. There we go. First list, L1. We don't need a L2 list. Frequency, 1. Okay, two tail. Okay, that's asking for a, we don't need to do that yet. We don't need to do that because we ain't got there yet. Well, I can't move down. Hello? Okay, forget it. Quit. Go away. All right. We'll just do it by hand right now until I figure out what they're wanting. All right. And what they're doing right here, we do have 1, 2, 3, 4. We got, what did I say, 12? 1, 2, 3, 4. Yeah. So we need to make sure it's normally distributed. Does it say in here that they're normally distributed somewhere? Confidence interval, confidence. I don't see anything. It's a random sample. And it does have a normal distribution because look. So I guess you could say it's a normal distribution. Yeah, one sample T. One sample. So let's go to the one sample. Let's go back to it. I knew they were asking too much stuff on the other one. So I'm going to go to stat, test, and just do t-test. Yeah, that looks better. And calculate. That's asking for a hypothesis testing because that's reject, fail to reject. Let's see if that's what they're getting. Let's see what they got. 60.67, yeah, t-test right there. See it? Standard deviation, 4.07. That's all it's going to give you. I'm looking to see. Now, it doesn't give the margin of error. But it's giving us the X bar. But we got to find the margin of error. So there's your handy dandy formula for the margin of error. It should give you the margin of error, and I think it will here in a few minutes. So let's go find the margin of error. So the margin of error is going to be T sub alpha over 2 times, what was it, the standard deviation over the square root of n. Wasn't that formula? Yeah. So we got to go find t, but we know our, let's see, our s, we got that right here, 4.075, and n is 12, so 4.075 and 12. Thank you. Over the square root of 12. And MOE is going to be equal to T sub alpha over 2 of 4 over the square root of 12. The square root of 16 is 4. 3.5. 9 to 12 is 3. Half of 3 is 1.5. So No, that's right, that's wrong, Hubert. 9 to 16 is 7, 3.5. 3.5 plus 9 is 12.5, so 3.4. So 4.05 divided by 3.4. So MOE is equal to T times 4/3 is 1.3. So let's go find our T. So we go to our handy dandy Google table. If I can find it. Where's our Google table? There it is. And 0.025, didn't it say 95% confidence level? And 11 is 2.201. Y'all got that? So we go back to our 2.201. So MOE.
I did it in the calculator and did not get 1.3.
Well, I'm just estimating, doing it in my
Okay.
head. What'd you get?
1.16.
Okay, 1.2. I'm sorry. Excuse me. How dare me?
Well, you can
Okay.
mess me up when I get home.
I'm just, well, if you've been here in the last 2 or 3 classes, instead of being all sick. Anyway, 2.201 times 1.2. And what does that come out to be, Miss Dyer? Let's get it down
What
to
is
the
it?
10,000.
I can't see because you're in the way.
Oh, okay, I'm sorry.
2.64 by
2 point what?
64 by
2.6412. So you got a 2.6% margin of error. Or 3. A margin of error is 3. And that should be what they got. The reason I'm showing you these like this is because, look at there. Well, ours is off because I didn't do all to the 10,000th and all that. But anyway, all you have to know is formulas and how to use the tables. That's all you got to know. You don't have to be rocket science. I mean, now, what does all this mean? Well, let's see. We got a mean and a what? Standard deviation. Well, you know what to do with mean and standard deviation. 61 and a standard deviation of 4. Okay? So you can make your bell curve and find out where your 95% falls. The margin of error, we're going to find a interval of your confidence interval, because that's what it's asking for, I believe, is the confidence interval. And there it is. Because we've got the mean, so 61, the mean is kind of like, your margin of error is kind of like your mean. Remember me telling you that the other day in class? You remember me telling y'all a long time ago, whenever you have a mean and a standard deviation, what was standard deviation? 2? What was it? I'm sorry, what? Okay, 4. So this would be 65, and this would be what? And this would be 57, and what? Okay, now in our previous sections, I told you to do this, and you know that 95% falls normal between 53 and 69. Now, we can take that same thinking and go, okay, our mean is 61, and our margin of error on the right will be added. What was the margin of error? 3%? So that'd be a 63%. And what would be on this end? 59%. That's right, class. Or 58%. Which one is it? 58? So, your mean, you've got a 95% confidence that your mean for your population, based on the sample, is going to be between 58 and what? 63, you don't need percent there, I'm sorry, because we're not talking about proportion, we're talking about mean. So you don't need a percent, I'm sorry. There. So now instead of your proportion or your whatever that we were doing in 7.2, but to being between a certain decimal or a certain percent, you know 95% confident, so you've got your chest poking out and you're feeling very confident that based on the stuff that you've been given, that the mean is going to fall between 58 and 63. So let's see if we got it right. 58 and 63. So the result would also be expressed in the format, we are 95% confident that the limits of 58 and 63 actually do contain the value proportion mean. It appears that the mean speed of blow is 65 miles per hour. So, do you feel good about yourself? I think you need to do another one. All right, try this one. 12 different video games showing substance use were observed. The duration times in seconds of alcohol use were recorded. Oh my gosh, some people don't have anything to do they? Listed below. The design of the study justifies the assumption that the sample can be treated as a simple random sample. Use the sample data to construct a 95% confidence interval, 0.05, 0.05 over 2, 2.201. An estimate of the mean. The mean duration, time, and the video showed the alcohol, use of alcohol. So write those down, or put them in your calculator, find your mean and your standard deviation, then go through and find your margin of error, and then find out where your mean is going to fall. And then you feel good about yourself. So what do y'all think about the Iranian deal?
What are we gonna do? The one about them getting nuclear bombs or whatever?
Yeah. What do y'all think about it?
I don't understand that. To be honest.
Well, we got one person out of 12 that says they don't understand it.
I didn't know anything about it.
Didn't know anything about it. That's even better. You'll need to start watching the news, people.
Like, are they basically saying if we don't sign this contract or whatever,
They're going to get nuclear weapons no matter what. Because they're not scared of us. They're not scared of us, and they don't respect us.
then what's the point?
I'm not going to say anything. I'm going to keep my mouth shut. I'm just going to wish and pray that 2016 to hurry up and get here, because I'm going to vote for every politician. I'm going to vote for everyone that's in there. I'm going to vote them out. I'm going to vote for whoever runs against Mickey Mouse. I'm going to vote for Mickey Mouse.
How do you feel about Donald Trump?
I love it. I love it. Because 1, he's a businessman. 2, he's a sensible businessman. And 3, he believes that political correctness is a bunch of bullcrap. So that's why I like him. And
I
he
don't
said,
even think that he actually wants to be president. He's just
yes,
doing
he does.
it. Like,
Yes, he does. And I can't wait for the first debate. Do you know why? Because he's going to put those politicians to shame. Because they have no earthly idea how to run a business. None. They don't have any idea how to run payroll. They don't know anything about taxes. They don't know anything about how China's whipping our rear end. They don't know anything. And he's going to make them look foolish.
So you don't think that Hillary Clinton will be elected?
Hillary Clinton will be elected if the Republicans are arrogant like they've been in the last 3 or 4 presidential elections. Yes, she will be elected.
I feel like Obama just set it up for her. Like,
No, Obama didn't set it up. They threw Hillary under the bus for Obama. The media put Obama in there. Period. No, Obama really don't like the Clintons. You just watch the news, they'll tell you that. And the Clintons hadn't got much use for them either. Do y'all know that? Oh yeah, they don't like them. They don't like each other. I would love to see Donald Trump and Ben Carson go into the White House. That's who I would like to see. Y'all know who Ben Carson is? Y'all have no earthly idea, do you? The top, most respected neurosurgeon in the United States.
why?
Huh?
Why do you want him in there?
Huh?
Why do you want him in there?
Because he knows how to run a business.
Do you think they have a high chance?
For right now, Donald Trump is number 1 in the polls. That's until the establishment and the plantation, they're going to get him. They're going to do something. They're going to try to find something on him. They're going to try to, but I don't think they're going to do anything with him. And those of you that don't know who Ben Carson is,
We have to look him up.
you don't have to look him up. You just have to Google Ben Carson. Some of you are going to be surprised. Why? A conservative? Yep. Number one, top-rated neuro. We're not talking about a Billy Bob doctor. We're talking about a neurosurgeon.
Gay people put to death?
No, that's taken out of context. That's Ben Carson. Now you know who he is? I'd like to see, let's see, what's his name, Walker? What's Walker's name? First name? Oh, y'all don't know. Atomic bomb could hit Anderson, y'all wouldn't know. That's going to be y'all's bonus question for the test. Scott Walker. I'd like to see Scott Walker also in there. And I would like to see Fiora. Fioria.
All right, what about the?
I don't know her name. HP woman.
18 woman for president.
There she is. You know who she is?
Nope.
She was the president of Hewlett Packard. The CEO for Hewlett Packard. But why won't you see her on the front lines or Ben Carson on the front line? Because the Republican Party's too arrogant. The Republican Party thinks they'll throw 2 stiff white rich guys out there, politicians, and America will just drop to their knees and say, oh, that's who we'll vote for. Well, it hadn't happened. Y'all know Dole, McCain, Romney. Didn't work. So they're going to have to, the Republican Party is going to have to put a woman or a minority on the ticket. They're going to have to. Or Billary will walk into the White House for a 3rd term. So now, Billary, what's Billary? Forget it. I think I'm going to put bonus questions on the test.
What you think
Who is
about-
Billary?
What do you think about that? What's the one that's from our state? And
He's a politician. Mm-mm. I ain't
So what's
voting
his
for him.
point in running,
I ain't voting for him. What? What's so funny? I'm not voting for any politicians. I'm voting the 4 that I showed you. And maybe the governor of Texas. He's not a politician either. He don't give a rat's rear end what you think about him. I like those people. I don't like these people that, yeah, I know what you're saying and I'll vote your way. And then they turn around and tell the other person on the other side of the spectrum, oh, I know what you're saying, I'll vote your way. Those politicians in Washington has got us nowhere, in my opinion. And I've got an opinion like everybody else. All right. Now, these guys right here, let's punch them in. Go to your handy-dandy table. Turn it on first. No. So what?
So you don't do this by hand?
Yes, you can do it by hand. You'll have to find the mean and standard deviation by hand. Remember we did in chapter 3?
Oh, yeah, well, I just use that.
Oh, yeah, I remember. Oh, forget it. Yeah, I would punch it in if I was you.
Okay, how do I get to that? 'Cause I don't know.
Go to Stat and Edit. Hit Enter for Edit. What this means is you're opening up a new spreadsheet. Okay? And type them in. And I type in 84. Enter. 14. Enter. 583. Enter. Oops. 583. 50. 0. 57. 207. 43. 178. 0. 2. And 57. Now you got them in. You got to put them in order. So go to Stat, Sort Ascending. That's what Sort A means. Type in second 1. What's above the 1? L1. That's list 1. So that's what you assigned in it. Close parenthesis. And just go back and check it. Second, Stat, Edit, and they're in order.
Yeah. Should we have to?
I'm sorry, what?
No, you don't. You just do it until it says done.
Yeah.
So if you type it in order, then don't do that way.
You can type it in order or you can make it do it. Okay? I don't like to if I try to type these in order, I'll be trying to type them in order and then y'all will be yelling out stuff and then I'll get it mixed up and no, 42 goes next and then I'll get mad and then I'll fail y'all all. Okay. Now, hit Stat. Now, you can do calculation and do first variable statistics, and that'll give you the mean and the standard deviation. Or you can just go over to test and do the t-test. And go down and, yeah, everything's, don't mess with anything. Whatever you do, don't mess with anything. And hit enter.
Why do you have 0.3 in there? For you?
It's just, that's just, I really don't know.
It's mine's 0. Mine's 0 too.
Okay, well, I don't think it changes anything.
Yeah, it does.
Okay. Okay, well, let's just,
It's B, I think.
all right, let's just do this. Let's go to Stat, go to Calculate, First Variable Statistic. There. There's your X bar, and there's your standard deviation. What do you mean, uh-oh? Oh, wait a minute, I'm sorry. First variable statistic, hit enter. There. All right. Now, there's your X bar, 106.25, and you got to look up sex. There it is. 164 is your SX. That's your 164. That's your standard deviation. Whew. So, what can you tell me about this data? I'm going to sit here till you tell me the answer because y'all should know what.
Mean 0.
What?
The mean is 0.
No, the mean is 106. I'm just going to sit here, okay? What can you tell me about the data? Look at the standard deviation, people. Yeah. That's not what I mean by look at it, just recite it. No, I don't want you to recite it. Go back to a lot of our mean and standard deviation problems. What is usually the mean? Let's say the mean is 100. What's standard deviation?
It's just like, yeah.
Okay. All right, then why do you think this one is huge? Because something is skewed. Something's messed up. Look at your data. You should have seen it when you first began. What's wrong with it?
It's way out there.
It's way out of place, isn't it? If you take that 583 out, then your data would be a whole lot more valid. Okay? It's kind of like having a 6-foot second grader. All right? What is a 6-foot second grader going to do to the average height of the second grader? It's going to make it 5'8" and 5'9", where second graders are usually what? 4 foot, 3 foot? All right? So the 6-foot second grader, or the 300-pound second grader, is throwing the average what? Off. Now, that's one thing you need to notice. All right? Another thing you need to notice is there's variation. That variation, that 583, it doesn't help. I don't know, what are these things again? Oh, watching how many minutes was drinking alcohol. This is ridiculous. All right, I'm sorry. I think our money can be spent. And why does it look like this? Because that 587 is just messing the data all up. If you take that 587 out, then you're talking about something easier. Okay, but don't worry about it. You've got your mean and your standard deviation. What does that do? Well, it tells you you can set this up. So mean and standard deviation. What was our mean? 106, and our standard deviation is what?
164.2.
So 164 would be what? 270? And 164 would be 430. Somebody help me out. I don't know. 164 would be 34. Somebody add it and tell me what you get. We're already in the negatives here. Why? Because 106 minus 164 is what? And you see two negatives here, big numbers, you know something's wrong. Something is wrong with this data, period. So normality falls between negative, is this 434 correct? Okay. What's these two numbers? Negative what? So, if you was to watch a movie and there was 30 minutes of drinking alcohol in that movie, would that be normal? Yep. What about 500 minutes? Well, 500 minutes would be a little bit over the top. But have you ever watched Denzel Washington in Flight? Oh, that is such a depressing movie. I will never watch that movie again. I don't like him in those movies. God, he drank through the whole movie. I'm not talking about a shot here and a shot. I'm talking about a bottle here and a bottle here. Oh, God. All right, so T. So let's find our margin of error. Margin of error is equal to T times, and what was it? S over what? Square root of N. So we already said that that's going to be 2.201 multiplied by the standard deviation, what is 164 point what? And what is N? How many? How many? 12?
Oh, yeah,
Okay, so that's 12. Square root of 12. We said that was 3.4. I can't remember if it's 3.4 or not. So that's equal to 2.201 times 164.3 over 3.4. 2 divided by 3 is 0.67. 0.67 is 2/3 of 164. So if I was to divide 164 by 3, that would give me 54, it's around 55. What does it come out to be? Calculated, what is it?
104.7.
I'm sorry, what?
104.
Okay, well, I was way off then. 104 what?
0.39. Second.
So you got 104% margin, or 104 margin of error. So that means that your prediction with a 95% confidence level is that your mean for your population, I guess. What? I got 50 something. What did
I
you
got
get?
106.36.
I'm still way off. All right, somebody do it all again and tell me which one's right. 106?
Times 164.3. There's 361.6243.
106.4. So 106. So our mean, I guess the population mean, I can't tell what they've given us right now, but usually the mean is going to fall between somebody, what's the mean? 106 here, and the margin of error is 106. It's going to fall between 212, right, and 0, pretty much. So, if you was to pick a movie, besides 28 days, because all the drinking in 28 days was done in the first 20 minutes of the movie. Anyway, then it's going to have somewhere between 0 and 212 minutes. And 212 minutes divided by 60 is what? Oh, yeah, I guess. I know. 3.53 or 212. I don't know how they're doing that 500 is throwing everything out of proportion. They really should throw it out. I don't know if they did all that, but let's see what they did. I don't know what the question's asking. They got 211 seconds. Seconds, I'm sorry. Seconds, not minutes. Seconds. What did we get? Well, I didn't do the decimals. I just did 0. I just took off. So, what did we get? I got 212. Excuse me, I got 212. Thank you very much. 212. Oh, I'm sorry. 211, and I did in my head 212. I'm sorry. Miss Dyer, you're a loser. So take 212 seconds and divide by 60. What is that? 3 point what? So in any movie you pick based on this survey or this research, it's going to be around 3 or 4 minutes of drinking in the movie. Unless it's flight. Okay? You see what you're doing now? I was going to find one more. Let's go to your handy dandy. Because I think I'm just going to test you on 7.2 and 7.3. Online students, I think I'm only going to test you on 7.2 and 7.3. Let me tell y'all something funny after class. 7.2, 3, and 4, I think. Wasn't it 7.2, 3, and 4? Okay. Okay. You're right. I don't know. All right. Estimate the population mean. All right, this says to construct a confidence interval using the given confidence level, do whichever of the following is appropriate. Find the critical value, z sub alpha over 2. Find the critical value for t, or state that neither, I don't want to do that one because I'm just going to do t-tables. Okay. There we go. All right. Use technology and given confidence and sample data to find the confidence interval for the population mean. Assume that the population mean does not exhibit a normal distribution. Well, it doesn't exist a normal distribution, but what does this mean? N is what? Which is greater than 30, so you don't need to worry about the normal distribution. So go ahead, take off. Good thing is the 95% confidence level, you know, is still what? 2.201? So you don't have to look that up. You could just quit. What's good about this problem? You don't have to find the what? One, you don't have to punch in any numbers, and two, you don't have to find the what? You're about to go out on me there, wasn't you? Mean and then... So what's the only thing you got to find here? The margin of error. So the mode is equal to 2.201 multiplied by the standard deviation, 5.4, over the square root of 41. Miss Dyer, please tell me what the square root of 41 is to the 10,000th power. Just tell me what the square root of 41 is.
6.40.
All right, and somebody give me the margin of error.
$1.8.
1.8. Give me one more digit because these two are to the 10th, so we might want to go one more digit. What is it?
857.
57. 1.86. So ours is going to be, the mean is 4, so that's going to be 5.86. And what is 4 minus 1.86? That'd be 2.14.
So how did you get it?
Huh? Well, how did I what?
What did they come
All right. Do you understand how I got this?
See, I got all
Okay.
that.
How do we do standard deviation? When we did that, we'd go 4. And then what? You add it on one side. Well, with the margin of error, you just take the mean and you add one. You add it to one side and then you subtract it from the other. So
That's
4 is right here.
Right.
What's 4 plus 1.86?
Okay.
What's 4 minus 1.86?
Oh, you Okay.
Now it says round to one decimal place, so we're going to go 2.1 and 1.9, but mine may be off because I did not. Huh? Okay, because I didn't do 6.045 here or whatever it was. 5.9. So let's see. It's probably just a rounding, which I'm not going to worry too much about. What was the answer? Yeah, that's because I didn't do 6.405 right here. And I got 5.8. Now, they say correct answer is 5.8 or 5.6. Well, I see I did 5 point, what did I do, 5.9? Yeah, see that's out of the balance. So that's because I didn't do 6.405. Yeah. That's it. But if you had this on a test, I would take it. Okay? You have to remind me, yep. That's squeaky door gets what? OIL. Mm-hmm. What does that mean, people? You get the points if you what? If you ask. I'm not going to go through and do your work for you. All right. Okay, let's get this problem wrong now. Is the confidence interval affected by the fact that the data appear to be from a population that is normally distributed? Well, let's look. N is equal to 41 and X is equal to 4.0 and S. What's wrong with this? Does this look like a normal distribution? Doesn't look like a normal distribution to me because the mean is 4 and the standard deviation is what? 5.4. I would say, well, probably the sample's not big enough because that's some small numbers right here. But I'll probably get it wrong. Oh, I got it right. So chances are it's not big enough. Okay. I'll try to give you questions that don't have a lot of stuff on it, okay? So I'm not going to try to confuse you. I'm trying to find one that, and I'll try not to give you one that does a lot of typing in. All right, let's see what this, okay, find the required sample size. Now, to do this, let's see if they give you the, and I don't have to, no. Let's see if they give it to you here. No, there it is. Okay, instead of looking in the book, they usually give it to us. There we go. Write this down. N is equal to Z times standard deviation over the margin of error, all that squared.
Is that A over B?
Alpha. Alpha over 2. That's what we did 7.2 and 7.3. Alpha over 2. That's why they give you the Z-table, because you need the Z-table for your sample space. All right, now let's read it. It says an IQ test is designed so that the mean is 100 and the standard deviation is 121. Now, just for giggles, and because I always tell you to do this, I'm going to draw it. What's the mean? 100, Hubert. Y'all wrote it down, didn't you? And what's the standard deviation? 21, Hubert. 121, and what would that be? 142, and 21 would be 79, and 21 would be 58. Right? What is this? IQ test. Find the sample size necessary to estimate the mean IQ score of a statistics student such that it can be said that with a 99% confidence level. So you go to your handy dandy page and you say 99% confidence level equates to alpha being what? What's the complement of 99%? 0.01. Good. Therefore, alpha over 2, what's half of 1 cent? 5 cents, Hubert. That's right. So what's half of 1 cent is 0.005. So we need the z-table. So somebody go to your z-table, or somebody do inverse norm 0.0050. That's 4 digits. What is that? Area. Good job. So you go to inverse norm and tell me what 0.0050 in inverse norm is.
Minus 2.57.
So 2.57 is your z. 2.5 what?
75.
75, which is 2.58. There's your z of alpha over 2. 2.58. Write that down. Y'all didn't eat this pizza. That's all right. Walt and I need supper tonight. Right, Walt? And Lauren, we need supper.
Forget about her.
No, I'm sorry. I'm used to having Walt all the time. Now, y'all supposed to eat the cheese in the middle. All right. What? What did I do? It was on the cardboard. What did I do?
There's no way that she wanted that.
Why?
Why do we supposed to eat the cheese? I don't understand.
Right here. It was right here on the cardboard.
I thought you took the pepperoni off the pizza.
No, I didn't touch the pizza. It was on the cardboard. Y'all think I'm that bad? Y'all can jump in a lake, all right? Y'all are all going to fail this class. All of them. You think I would pick something off the pizza that y'all eat?
Yeah, I thought you like took the pepperoni off.
No, y'all got it off the cardboard.
Oh, God.
Oh, anyway. All right, so. Y'all gonna miss me. All right.
Oh.
Now, let's look and see what else we got. Do you notice what I'm doing while I'm reading these questions? I'm writing down all this stuff to try to get a grasp of what the questions say. Because I don't want y'all regurgitating stuff. Regurgitation, you're not learning anything. I want you to write it down, draw a picture, understand that the question is saying, okay, this data is giving us 58 to 142 normality right here. So, I need to find a 99% confidence level and find out how many people I need to question or research to get this up to this. That's basically what it's saying. All right. Within 7 what? What's that within? That's 7. So the margin of error is what? Good job. Assume that standard deviation 21, we already did that. Okay, so here's our handy dandy formula right there. Z sigma over E squared. Z sigma over E squared. Z Oz over, what's on the bottom? E squared. Oz over E. So, what's our standard deviation? 21? 2.58 over 7.
Is it not negative 2.5?
Nope. Remember, we always use the positive. You didn't watch the video.
I did.
All right. So, let's see. That's 3 times 21 is 63. So it's around what? 9? Somebody tell me what the answer is.
I know I can see anyway.
You got all the numbers? Oh, yeah, it's awful to look at the paper right there under your hand. What?
7.7.
Okay, 7.7 what? 7.74.
And Cradle to
7.74.
59. No, no,
So if we have a decimal, what do we have to do?
but if we're squaring it, yeah.
Okay, I'm sorry, squared, 7, be 49, so what is it?
59.
59 what?
907.
So that means how many people?
6.
We gotta research 60 people in order to get a 99% confidence interval. Now you see how it works? Everything is based on the 90 to 99%. Depending on how much you're paid, depends on how much you need to be sure. If you're working minimum wage, then 90% is good enough. If you're getting 6 figures a year, you better make sure you got your stuff squared away. And I would hang around this guy. I would base all my research on 98, 99%. You feel good? Good, let's do another one. Now, I'm going to let y'all do this one by yourself, because I want you to be discouraged. Let's see. All right? Blow it up so everybody can see it, Vanna. Please. Freeze it right quick, and I'll go ahead and do the attendance. I think everybody's here today anyway. Oh, yep. Well, we'll just make everybody be here today. We'll give everybody the benefit of the doubt today. Since it is the last day. Today's the 16th. Okay. Now, the range, the rule of thumb is to take your range, pretty much, what's the range on this problem?
606.
And divide it by 4. Because that's how many sections are in between the 95%. Got it?
10,000 divided by 4.
Whatever, yeah. 250. So the standard deviation is 250. Unfreeze it and bring it down, please. How many sections are right there?
4.
That's why you divide it by 4. So, your standard deviation by the rule of thumb is equal to 1,000 divided by 4, which is equal to 250. And hopefully you didn't have to use a calculator for that. Say again?
That's the range. 600.
The rule of thumb is the range over 4, because of your 4. section that are in the normal region. Some of y'all are going, oh, I see where the 4 comes from. That's a good thing. Okay? Now, it says the student wants to estimate mean blah, 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 blah. With the score, we use technology and estimated standard deviation to sample size corresponding to a 99% confidence level. Good, that's 2.58. And a margin of error of 100 points. Okay, so let's do that. I'm just going to go to the white page. 99% confidence level. Is 2.58. So Z sub alpha over 2 of a 95% confidence level is equal to 2.58. And what is our N equal to? N is equal to I's over what? Over E raised to the second power. Don't forget that second power. And that's going to be 250 times 2.58 over 100 raised to the second power. Well, what is 250 divided by 100? What's this 6 here for? I should have 12 people saying 2.5. I think somebody said 4.
Huh?
What's 250 divided by 100? 2.5. So N is equal to 2.5 times what? 2.58. Well, the easiest way to do that would be multiply the 2 times 2.58, which would give you 5.16, and then take half of 2.58, which is, so that would be 5.16, and then take half of 1.58, which would be, or 2.58, which would be 1.29, and that's going to give us 6.45. What do y'all get?
That's ridiculous.
What? What's ridiculous? What?
That's it.
What's ridiculous?
Since you did all that work.
Oh yeah, using my head. Yeah.
But you make it
It's-
sound so complicated. Let's take half of this and then
Well, what do? Do you want to sit here? Okay, I'm sorry. Let's do it the easy way. 2.58 times 2.5. 5 times 8 is 40, bring you 4. 5 times 5, that's 29, bring you 2. 5 times 2 is 10, that'll be 12. Then we got to put an X here, then we got to put a line here. 2 times 8 is 16, bring you 1. 2 times 5, that's 11, bring you 1. 2 times 2 is, that'd be 5. Now we got to bring this down, that's 0. 9 times 6, that'd be 5, bring you 1, that'd be a 4, and 6. Yeah, that's much easier. What's this 6 cent for? All right, so 6.45. What are we finding? Well, we got to take that 6.45 and we got to raise it to the what? Now, use your calculators to do that. What is it? Say again?
41.6.
Which rounds to?
42.
So you need to research 42 people in order to get a 99% confidence interval based on rule of thumb standard deviation. And that's what happens when you don't have a standard deviation. You take your range and divide it by what? 4. So let's see if we got it right. What did I say, 42? Wait a minute. This wanting the range of thumb, 250. Fantastic. I would love to program the little windows that go in here. Wouldn't you love to do that? You are stupid. You got the wrong answer. McDonald's is hiring. A confident level of 99% requires a minimum sample of 42. And we feel good about ourselves. Oh my gosh. Well, we did feel good about ourselves. What isn't quite right with this exercise? Well, I can tell you what's not quite right. That's the standard deviation. But anyway, these results don't apply to a test that has multiple choice questions.
That makes sense.
The range rule of thumb introduces too many inaccuracies for this procedure. I agree with that. The margin of error of 100 points seems too high. That's also true, but you're talking about a mean. So a mean could be, if you were talking about percent, it'd be different. But I could get by with C. A minimum size of 42 is not feasible, no, because you've got n is greater than 30. So I would say it's probably B.
But it's gonna tell you it's not.
It's going to tell me it's wrong, so. C. So I ain't going to hold you to that. All right, let's do one more. I'm going to try to get by with not doing a bunch of looking up stuff. But I don't think it's going to give me that. Let me try 7 down. All right. Using the simple random sample of weights of women from a data set, we obtain these sample statistics. N is equal to 45 and X bar is equal to 151.74. Research from other sources suggests that the population of weights of women have a standard deviation given by blah, blah, blah. Find the best point estimate of the mean weight of all women. And then find a 95% confidence interval estimate of the mean weight of all women. I'm sorry, what? That means it's your T-table. Find your T-table. You're going to have to use 95%. So it'd be 95%, 0.5, and what's half of 5 cents? 2.5 cents. So that'd be 0.025. So you're trying to find 0.025, isn't it 2.201? So that'd be 2.201 if they want that. Unless they want me to round. Unless they're using Z-table.
So really, we don't need X bar.
Hold on a minute. I'm trying to figure out what. Oh, the best point estimate is the mean. I'm sorry. Go back to your statement that we did back at the first of the chat section. What's the best point estimate for a set of data? The mean. So that's why it's the mean. I'm sorry. I was thinking T-table. All right. Forget the T-table. Just it's the mean. All right. What was your question, Ms. Dyer?
Never mind.
Now, just do what we've been doing. Find the 95% confidence interval. Estimate it. So you need to find the mode. Big mode, little mode. Not the big mode, little mode. But just the mode. MOE is equal to your T score multiplied by what? I don't forgot it. It's the standard deviation over the square root of n. Somebody help me out. And don't square it. That's just, yeah. So MOE is equal to 2.201 multiplied by the standard deviation in this case is 31.21 over the square root of 45. And somebody work out all that and give me the MOE. Round to 2 decimal places. 10 point what? So our confidence interval is going to be, mu is going to be between, take 151.74 and add 10.24, that'd be 161.98, and subtract it, 141.5 what?
That's it.
50. That's your interval. I'm just going to type in 3s. Because I'm being lazy. It's the last day of class. 142.62. Okay, we did something wrong. Y'all check my math here. We a little bit off. Standard deviation is 31.21. Did I look up the T number wrong? What's the O? Oh. We did the, I know what's wrong. N is not 12. N is 45. What's the degrees of freedom? 44. So we got to go back to the table and do 44. And 45 is right here. So that'd be 2.014. 2.014 instead of 2.201. So that was my mistake. I forgot to tell y'all to do that. Have a good day. Get mad and leave. All right, I done lost it. 2.014. Now do your math. 2.014. It's right there. What is N? Huh? So what is the degrees of freedom? 44. So you find the closest number to 44, which is what? 45, and you go over to 0.025, which is at the top, and that'll give you this number right here. All right, what'd you get? Instead of 10.24, what'd you get?
9.37.
And then add that and subtract it. 9.37. What will that give you on the left side?
1.11.
Okay, 161.
That's still not right.
Well, I don't know what's wrong then. What did they get? Hold on. Let me get it. Oh, I can't find the problem. We got something wrong. All right, take the standard deviation, 31.21, and divide. I'll do it.
No, that's right.
31.21 divided by square root of 40, what? 45? 45 raised to the 0.5 power. And that gives you that number times 2.014. Oops. 2.014. 9.37 plus 151. Oops. 151.74. I don't know what we're doing wrong. Unless I looked up. Let me see. Let me look at their T table. 0.025. 45. Unless they got 44. No. 45 is 2.014. Hold on a second. I want to see what they're doing because I don't know what they're doing different than what I've been doing. It's a conspiracy. I can't find my problem. There we go. Oh, I hate these things. All right, is that the formula we're using? Right there. Alpha is equal to point, they're using the z-table. Now, why are they using the z-table? Why are they using the z-table? Begin by finding the critical value z, while either technology is necessary to be found using the z table. But why are they all of a sudden using the z-table when they told us to use the t-table? Hold on, let me look. I need to figure this out.
Let's call it.
Yep. All right, let's look back here. Okay, using a t-distribution table. Now, there's got to be a reason. All right, what does it say there? T, T.
So you use the z-table and the other.
I'm trying to figure out why they're using the z-table.
No, I'm saying the z.
I'm trying to figure that out. This is true, author dedication. Gossett first referred to his distribution as a Z distribution, but it was modified and then later called it a T distribution. Here are some of the key points about the... Oh, that sums it up. I mean, nothing on here says anything about... Do y'all see anything?
Nope.
All right. Just for giggles, let's see what the big difference is on the z-table. I want to see what the number they're using. I want to see if there's that big of a difference. And then we got to figure out why they're using the z-table. Wait a minute. Let's go to the... Let's get out of this. Go to view an example and see what they say. Nothing that says z-table. There's got to be a reason. All right, I'll have to figure it out. I mean, I'm going to try to stay away from these because the ones we were doing were T, but let me find the z-table. Where's my...
Why would they do it if they don't even offer you the z-table?
I know, I don't understand. I don't know. What's my negative 2? What's 2 point what? 2 point what? 0.0250, is that what it was? 0.0250, 0.0250, 0.025. I'm looking. Here we go. There it is. Negative 1.96. So that's 1.96. So somebody take 1.96 and use that. Take 1.96 instead of the 2.01 and see what that gives you. 9 point what?
You got the right.
Does that get it right that time? They're using the Z table. Now, so that much, they should give you both answers. Why don't they give you the T answer and the Z answer? There's got to be a reason. Okay, we got to figure it out before y'all leave, though. It's got to be something simple.
You're fine.
Tom Demain has been committed to making the world.
Whatever. Let me just see if I can get some kind of...
How to calculate the principal for the population mean. Now where students go CM, this which table we use
Look, it says T or Z.
important, and this is the bit where students make mistakes. So first
Okay.
I'm going to start out with a bit of detail, and then I'm going to try to simplify it as much as possible, but obviously I
Okay,
will
shut up. All right. Variable normally distributed where sigma is known. Okay. There it is, right here. If sigma is known, if you know your, did it say that in the reading? I don't remember it saying that. If you know your standard deviation, then you use the Z table. If you don't know the standard deviation, you use the T table. Simple enough? I think that works. Evidently, all of the problems that we were given, evidently we didn't know the standard deviation, or we had to calculate it, one of the two. If you have to calculate it, then you use the T table. See what I'm saying? I didn't know I didn't see that in the introduction. So I'll try to keep the test ones to problems that are T table, okay? And if I do, just if you see one and they give you sigma is equal to 2.5, then just remember that you have to use the Z table when you have sigma given. Okay? All right, so just to reiterate for everybody, I'm just going to go over a couple of things before y'all leave. I know y'all got to go to the fire. I still got like 10 minutes. All right, so your last test will be on chapter what? 7.2 and 7.3. It will end, if you notice I changed it to 7 when? 23. And the reason that is I have to turn in grades at 8 o'clock in the morning on the 24th. All right, your final exam will end on what? 7:23. Now, if you notice, I put 5 p.m. Why? Because my department head wants them in before dark that night. Wants grades in before dark. That way she don't have to worry about them at 8 o'clock in the morning. So she wants them done. So I got to do my grades. What day is the 23rd on? Friday? Thursday. So I gotta do my grades on Thursday night,
So basically, everything is done by Thursday.
pretty much. I changed everybody's, I changed everything. So that way everybody have a chance to redo their homework, redo their test, anything you need to do, get it done before 5 o'clock on the 23rd. Okay?
Sounds good.
All right,
Well, thanks for the feedback.
good luck.
You fine?
Yeah, I'm gonna stick my finger in all of them, all of them.
We're trying to get you see the paper over here.
See, here's where the cheese was, right there.
You didn't get all of it.
I did. Y'all have a good summer.
You said.
Glad y'all had me this semester.
We are.
I delete my
You deleted your
line
what?
here.
Oh no,
How do I do it?
I have no idea. Let's see.